So I was trying to use my new Triplett 630 NA to measure resistance across this soldering iron here. This it's a 24 volt 48 watt, very cheap, with a temperature probe. It's actually a very cheap Asian Chinese soldering iron that goes to this old station over here. I was gonna get it going again, check some voltages, found out that the station was putting out plenty of power just for the second time now. I think the heating element went, but I want to check the plug here, because if you look at it, I believe the bottom two pins are actually just a dead short, which tells the unit that the iron's present. Otherwise it beeps at you that's not plugged in. And I think the top two are for power, but I may be wrong. The bottom two may be part of the temperature sensor, but or something. I was just trying to use the old meter to get some numbers just for fun before I, actually start figuring out what's going on. Well, anyway, here I was trying to test resistance, and I'm not kidding you. Here's the wires. I mean, that's, there you go, see the whole wire. That's what was not touching going into this, and you'll notice we're not at zero, or it shouldn't really be zero on the ohm scale. It should be at infinity if they're not touching, which is all the way to the left. It was taking some strange measurements, and I'm in the 100K non-divided range, and it did that. I'm gonna try to touch them together here. Sorry for the horrible camera work. I'm just holding this with my up. There we go. All right, all the way up, and now look at that. It's going up, not quite to zero. Let's put some pressure there. No, not quite zero. I mean, I can adjust that, but funny thing is when I'm letting go, why on earth is it like parking itself there? And it's not stuck. You'll see it's bouncing below, and then you see, watch when I release, and it bounces to about just below the 80 mark, and now you can see it's halfway between the 80 and the 90, so it's not like a stuck point. It's actually 75. If you look, it's going down to about 75. So I mean, I can try to get some momentum going. It's not a stuck needle. Oh, it just bounced around its own. I wasn't touching it. It's something going on. Let's change scale. Oh, look at that, straight down. Nope, not quite zero. Oh, just for heck of it, let's. Oh, there you go. I've pulled them out. Look at that. 100K range. I have the 30 volt, and I have the 1.5, and I believe they're installed correctly. Look at that. It's moving. If you look, it was actually moving there. It is moving. I don't know if you could see that on the camera that I stink at holding. Let me see if I can stabilize the camera some. There you go. You should be able to see that. You'd see that. It's moving. This isn't from my shaking. It's definitely moving there on its own. Here, put the lens here. Yeah, let's put the lens. And then that lens will go over this. And we should be able to just park this here. Just to stabilize things a bit. So there you go. Now you can see it. It is moving, which is bizarre. So it's moving, and it's in that range. Trying to hold the lens here and so you can see close. In the 10 range, it's just going down to there. And the 1K range, so now it's doing this. Oh, we're almost at zero, but we're not quite. Let's try the divide by 2. Yep, we're getting readings. Look at that. The 1K, it goes up, and then the 10K goes down, and the 100K, it just goes kaboom. Let's turn her off. Yep. Yep, we already have power. It's a big, it's a lovely selector knob. I mean, it's real meaty, but I just kind of got it propped up on a table vise here just to, so, you know, can't, you know, fault it for having like a cheap tilting bail that, you know, I watched a video, somebody made a big to-do about pushing the buttons and the meter just flopping over. But this one actually is it's pretty stable with them. You can push the buttons all you want on paper. But yeah, that's what the Triplett's doing. Woo, hello. Let me turn off divide by. Wow, look at it's moving too. And that brings it down there, like to very specific places too. You got about 3 on the scale, so that would be 300K, and then divide by 2, you're at about 0.75. It's kind of strange. And it's not like the knob. It's coming back to the same exact points. I can't really see any. You know, this is working. The zero out, the zero adjust is functional. It's not like it's scratching or something. And look at that. I can actually zero the meter out with nothing attached. That's turned all the way down, and that's all the way up. A little further back we're at 0, and all the way down parks us there. So I don't know what is going on with this meter. That one beats me. I'm gonna open it up and see if I can find anything. Oh, that's 6,000 volts. I don't know if I'd use this to measure 6,000 volts. I think I'd want something that says category something rated with these recessed safety safety shrouded. I don't want tips that have like a cover coming up. I don't know if I'd want to just take these rinky-dink things here and go hooking 6,000 volts up to these lovely lousy wires that are. There's one of them has some insulation missing. The only other thing that's comes to mind here is that if you look at the meter, this capacitor here, I mean, if you just look across it, there's absolutely, you'll notice zero ohms. My meter says 0.1. I got 0.1, 0.2, which is 0 ohms across this capacitor. So this is the cap right here, and this is just it's just kind of clotted up here, so it's easy to get to. This isn't leak, this is just the material. So it's easy just to get to where this is soldered to, and where the back lead soldered to right here makes a good test point. And you'll see it cycle down through all the ranges, you know, mega, kilo, ohms, and it's at like 0.3. If I probably dig the test lead in a little better, I probably get to that 0. But there you go, 0. I had 0 for a second, a 001 now. All right, fine. So this cap is probably completely shot and basically a dead short. The only other thing I found of note with this thing is that I tested some of the resistors in circuit. Yes, I'm aware that's wrong. Just to get a rough idea, if anything just looked berserk. And there are a few are the precision resistors back here, I noticed. That really did seem significantly out, and actually it was really these here, not so much these black ones. I think they're wire wound. I think these are wire wound resistors, and I found they were way outside of spec in circuit. These are actually very high. These are plus or minus 0.5%. So that's 0.5%, not 5%, 0.5%. And these over here, I think that says 0.25. There you go, 0.25%. Probably the highest precision resistor I've ever seen. 0.2, quarter of a percent. And this one is, yeah, 1/4% as well. This one's looks like it says 0.5%. So quarter, and 0.5%, and they were off, dramatically. Like probably off by more than 10%. So 10-20% off. So that those I don't know what this is supposed to be. It looks like a wire round. I don't quite know, because there's a wire coming from here that wraps around this thing, but it looks like the wire just kind of goes through, unless it doesn't go through, and this is what connects it into end. I don't know. These are definitely before, this one's definitely before my time, so I'm sure that I have the specs that'll tell me what this is and what it's supposed to be. But I just put these, you'll see these zip ties, I just kind of put them around the resistors that looked suspect, that need to be checked. So it's really like this whole section from here to here. Maybe that was a certain part of the range that was maybe abused. And then somebody's already taken the liberty of desoldering. You see the two solder joints here, one in there. So this thing's actually been desoldered. They didn't solder it back, and I thought this was part of the switch movement, but it's not. God, look at that. Amazing. It's actually I call it the caviar case, because it's like this little, special, the special ones go in here. And if you look, it's just kind of parked here. It's held down by this screw. And then these wires, this green one, this red one, it's a white wire, and a black wire. So these 4 wires connect it to the rest of everything, the massive multi-stacked switch assembly. But these are kept like in a very special, like I call it like a caviar dish. I thought this was just kind of some back of the axle, sort of something in there, but nope, it's just a dish for the special resistor. They don't look too crazy. There's a 20K 1%, 2.7K, 20K 1%. These are not like the ultra. You got 1/4% right here. So I don't know why these 1%ers needed to be, unless I'm misreading it and they're 0.1% or something nuts. But you get some kind of diodes going on in there too in the center, and then these look like IBM ceramic capacitor. Let's see if we can show that here. Give me a sec. Let's get the lens, and it goes this away. Oh, hang on. So take a look. You got like this. Put some light on that. IBM. I don't want to mess with it too much. That focus distance, yeah. IBM. That's impressive. Yep, says IBM on it as well. I don't know my capacitor codes off the top of my head. I'll have to look those up too, but don't know if I'm getting this in focus much or not. I probably need more light in there. There we go. Got some more light in there. Oh, it's probably focused by itself. So yeah, that's what's going on there. I thought that was interesting. I call it the caviar dish. But yep, got that magic 30-volt battery. I got the 1.5 volt D cell. When you measure ohms, it uses the 30-volt battery, I think, in this the 10 and the 100K. I don't know if it uses it in the 1K. And then the 1.5 volt D cell battery it uses for the lower ranges, but in the higher ranges it switches to 30 volts. So you do have to be aware if you're checking resistance with this thing and you put it on that 10 or 100K range, you are going to be sending 30 volts through your device that you're testing. So that may not work out in some of today's modern circuits very well. So, well, that's where I'm at with it, and it's still has this issue where, yep, it just it's doing that all by itself. See, this range isn't zeroing. This range is there. I mean, it shouldn't zero. It should go to infinity or zero on the needle. Because of course, when you're measuring resistance, it works backwards. But there should be no energy with nothing connected to the terminals. There should be no energy getting to this needle. How on earth do we have this much energy reaching the needle to push it so far over? It's measuring fairly low resistance, about 50K, I guess. If it's 100, if that's 100K and that's zero, it's measuring about 50K of resistance. Well, how is this much energy reaching the needle? That's got me. It's a heavy switch, but that's a tough one. Really, but that's not messed up. It's not the zero potentiometer. That's working actually fine. See, I can lower it to there, and I can increase it. But see, it can go to here, and then I can turn it about another quarter of a turn. It doesn't really move the needle much. Anyway, that's where I am with it.